Hello, everyone, and welcome to today's SD Times live presentation. It's called Cloud Engineering Generation DevSecOps. I'm Dave Rubenstein, Editor-in-Chief of SD Times. And before we get started, I just have a couple of brief announcements. First, today's presentation is going to be followed by a live Q&A. So at any time during the session, if you have a question, just go to your control panel, to the questions tab, type it in, hit submit, and we'll either answer them live during the presentation or afterwards we'll address as many as time will allow. Second, this event is being recorded and it'll be available on demand on the sdtimes.com website beginning tomorrow. Okay, so as we've been documenting in articles in SD Times over the last couple of years, today's developer looks nothing like the programmers we were used to 20 years ago. Back then, they wrote code and they really didn't have to worry about things like testing or deployment or security or regulatory compliance. Well, fast forward to today, and developers are being asked to take on more of those responsibilities, often without enough training or support from management to be effective. So to dive into this a little more deeply, joining us today is Peter Chestnut. He's the CISO of North America for the security company Checkmarx. And he'll be talking about the changing role of the software developer and cloud engineering. So Peter, take it away.
Thanks, Dave. Appreciate it. All right, welcome everyone. Thank you for attending. So I'll tell you a little bit about myself. If I can get this to move. I am a developer, so I know that my title is CISO, but my tribe is developer. I've been a developer for 30 years, very proud of that. And no matter my job title or function or reporting structure, I always consider myself to be a developer. The last 15 years I've spent in application security. I've done lots of things. I've used all of the major models for building software. I happen to be a DevOps practitioner. I love it. I think it is the way that software should be developed today. And I'm coming here today to talk to you about cloud engineering and that kind of stretch that's going on in the market today. Tell you a little bit about my employer. We are an application security testing company. We have a couple thousand customers and leader in the Gartner Magic Quadrant for application security testing with a wide range of tools, including SAST and DAST, IAST, software composition analysis, etc. And a little bit about my web development experience. So as I said, longtime developer. I started developing web applications way back in 1996. You see here a picture of Netscape Navigator. This is what I found on my desk at my first startup company. I came in and there was a shrink wrap copy of Netscape Navigator and an Internet Explorer. So for those of you that don't know, in those days, you actually had to pay for browsers. And of course, the web technologies back then were very rudimentary. In fact, I was using IIS before the active server pages were developed or created, using a technology called HTX and IDC. So there was a HTML template file, and then you would take this Internet Database Connector or IDC. It would run queries and it would fill in that template with the query results. So, like I said, very rudimentary technology back then. In fact, when I edited my web pages, I used something called Visual Notepad because front page was extremely painful at that time, and there really wasn't another good solution for building web application content. I'd like to talk to you a minute about DevOps. And every presentation I've seen and every person I've talked to has a slightly different way to think about what DevOps or DevSecOps means and how it should be used. And for most people that I talk to, it's something around here. where it's deploy, operate, monitor. It's people that create the tooling and the scaffolding that allow you to release your applications. So it is a kind of like an extra IT team, and their job is to make all the development team's job easier. And I will assert that that is not the best way to get the benefits out of DevOps. For me, I ascribe to the Amazon you write it, you run it model. And really the reason for that is that when you have to clean up after yourself, when you have to respond to incidents, when you have to be woken up in the middle of the night because you're on pager duty that day, and see that your work isn't as good as you think it might be, and that there are opportunities to improve. Without living that pain, you don't change the way that you code. And this is really, this was proved out with quality. The fact that you used to be able to write software, as was said in the open, write software, throw it over the wall, and quality will tell you whether it works or not. Once you pass the compile test, you're good. And because you didn't have to live with those consequences of slowing you down, then that's how you operated. And as soon as we started getting into this model where it actually has to work, we started getting into test-driven development and being better about writing our unit tests and our automated functional tests. So in DevOps, it's really about living the pain and operating the software to make you a better developer. Engineering continues to change. What I want to draw attention to here is really what's happened in the last 5, 6, 7 years. And this is something that I saw back then as I was looking at the marketplace and looking at how engineering was moving. So let's take a look at what happened back then. We were just starting the work. And of course, you had your unicorns out there that were far ahead. But for most of us, the architectures were moving to microservices. We were changing our team sizes. The move from waterfall to agile and that classic 2-pizza team was starting and really getting underway there. And we were talking and thinking about DevOps. Now, of course, DevOps just celebrated its 10th anniversary in Ghent. But those were the leaders and we're the laggards. So that methodology was catching on. People were trying to figure it out. And that pace of release, as you start to embrace what Agile can do for you and what DevOps can do for you, you can increase your rate of release, which of course has its side effects. So with all of these changes, I started to look at a different hiring profile. It wasn't about a full stack engineer, someone that could run, write JavaScript and write database queries and, do all of that stuff. That was important, but it wasn't the only thing. It was more about being multidisciplined, and we'll get into that in a couple slides here. With the shrink of your team sizes, in Waterfall, you've got all these experts. Once you shrink this down to 6 to 12 people, now I have to have a cross-functional team. And this brought about what I'm calling right now the continuous knowledge gap. And we'll talk more about that later, but this is really the idea that there are so many new things for you to know and learn and be good at. It's hard to get there. And so every time you learn something new is there to learn. So it's this incredibly fast-paced environment. And no one is being patient with us. The business wants it faster, they want it better, they want it cheaper, etc. So if we take a look at your model here, when we went from that monolith to microservices, the reason that you went from and started moving away from the monolith was because as it grew, it became brittle, it became complex, it was riddled with technical debt. So it was very hard for us to keep up. But on the plus side, of course, it's making us money, and we need that. So what are we going to do? So as you move to these microservices, you're trying to find these models to strangle the code and move pieces out one piece at a time, and that's extremely difficult. It's in theory very easy to do and very easy to understand, but in execution it's very hard. And of course, you need to support the old application. You've got to keep shipping it while you're building the new one. So you're like building the plane while you're flying the plane. And at the same time, not only are we trying to rewrite the application, but we're training our teams. We're training our teams on how to do Agile. We're training our teams how to do DevOps. We're training them on some of these newer technologies. So the transformation of methodologies, when I started, it was waterfall. So you had lots of people, 50 or more was not uncommon. And of course, with all those people, you had lots of specialists. I remember having teams where there was a job role called DBA, and there may even have been multiple DBAs on your project. You had people that were UX experts. You had people that were quality experts. So with that large a team, you could afford to do those things. And of course, the pace was extremely slow. One release a year, maybe up to 4. If you were doing it pretty well, maybe you could get 4 releases a year, but that was hard. As we transferred into Agile, now again, we're moving from 50 to 6 to 12, that 2-pizza team. People still had that specialization, so we're taking that same team that was doing waterfall, we're moving them to Agile, and now we're saying, okay, now you guys are going to be responsible for it. So we are trying to cross-pollinate and cross-train each other. We're now moving up the pace. We're 8 to 24 releases a year. So we're really cranking along here and making lots of mistakes as we go and learning as we go. But Agile, it's all about decreasing the risk by decreasing the size of the work that you're trying to ship in what they call sprints, if you haven't done that before. Now, when we move to DevOps, it's that same 6 to 12 people. I most often see DevOps run in Agile Scrum. It makes a lot of sense. It's a great way to think about how to structure the work. But here, what we're talking about is in Agile, you take a sprint, which is a time box, and you say, hey, we're going to take in some work. At the end of the time box, we're going to ship this increment. So you have the sum total of the work of 6 to 12 people, we ship it out, and then we rinse and repeat. With DevOps, it's one piece of work. If you are doing it well, you take one piece of work, you pick it up, you do it, you ship it, which means that you've got to be responsible for the whole smash, everything from the coding, the testing, etc. So this is the you write it, you run it model. So let's talk about how we are stretching, and this isn't just engineers, this is security professionals as well. And in fact, it hits security professionals in a very specific way, which we'll get into. We'll start with open source. Now, if you are not familiar with your open source inventory, I will tell you that nobody writes applications from scratch anymore. We used to lovingly handcraft everything and rewrite stuff from the ground up. We don't do that anymore. We rely on components that have been written by others, vetted and used in thousands or tens of thousands of applications. When you ship an application, it's typically 80 to 95% open source components inside of that software. The developers take it, they sew it together, and they sprinkle in, that those functions that get you the money from your customers. Now, unfortunately, we treat it like this. We treat it like a free lunch because it is free in theory. You can come in, use it as you like. There are certain licenses which aren't quite as free as you might think, but largely we're talking about something where you can use it in your application and you can sell your application. The problem, though, is that it does come with responsibility. So it's less like a free lunch and more like a free puppy. It needs care and feeding to do it correctly and to do it well. When developers use open source, and I know this because I am one, we integrate and abandon. Once I take a component, integrate it into my application, and get it to work, I don't look back. Why would I? It does what I needed it to do, and I'm done now. Open source software, however, ages like milk, not wine. It doesn't get better with time. And you have to think about, and we'll get into this in a little bit later, you have to think about keeping it current. And this is about good hygiene. And it requires some discipline on the part of the company because this isn't a security problem until it is. Open source, when it ships, we don't really know much about it. Security risks, or what they call CVEs, or common vulnerability enumerations, are discovered over time. So it ships with those vulnerabilities, but no one knows about them. So you integrate it, you abandon it, and then sometime later, sometimes years, you find out that there's a security vulnerability, and now you have to react to it. API first development is the norm now. When you build an application, you think about different kinds of interfaces that you might want to build on top of it. So there might be a web UI, you might have a mobile interface. You are usually now starting with an API and building on top of it. So no more is it all of my logic sits in an ASP page or a JSP page. Now it's, hey, go get this data, and then I make use of the data. Or go perform this function and then get the return of that function, and then I'll build the interface on top of it. And one of the big reasons for this is for me to be able to write automation. One of the great things is now I can automate my testing, or I can automate my usage. We started to do this so that way customers could run web applications in a headless mode to allow them to, for instance, maybe generate reports, do some data extraction. And also, again, the benefit for us is we could automate the testing and put many kinds of UIs on top of, or interfaces on top of those APIs. Securing these things is hard, though. You have to think about them differently, and it's very easy to make mistakes. And in the vendor space for the security market, the tooling is still maturing. This isn't your SaaS model. Where it's been around for over 15 years. This is a new and emerging market where we're trying to figure out how to do this well. This is a big one. Infrastructure as code. When I started, I wasn't responsible for deciding what operating system we ran on. I wasn't responsible for standing up machines. But that's the world that we live in now. Developers, when they write Terraform code to create the infrastructure in the cloud vendor space, that's essentially what they're doing. Through code, they're racking, stacking, cabling, installing all that stuff into that cloud provider. And we were never trained on how to do that. We had specialists, go back to that waterfall model. We had specialists, that was their job. They knew what hardware to order. They knew, what configurations needed to happen, how to harden the operating system. And this again is where we run into some problems, because we treat infrastructure, and this is legacy, we treated infrastructure like pets. We would give them cute names, which meant that we had some affinity now with them. They meant something to us. So when things happened on a machine, we would try to heal the machine, and like you would a pet, where really we need to treat it like cattle. And the whole strength of infrastructure as code is it is highly repeatable. So you don't have to log into a machine, change the configuration, though you can, you shouldn't. And the way to think about this is we repave the road. If something's wrong, I'll fix it. I'll fix it in code that generates my infrastructure, and then we'll repave the roads and move on. So again, are we lovingly handcrafting our infrastructure, or are we, think of this like the CNC routers, or am I coding the machine to be able to build me these parts repeatably and quickly at scale? We are not done with this cloud journey. Back, 5, 6 years ago, serverless was a brand new topic. There are newer technologies on the horizon that are going to stretch us in new ways, provide new functionality, or it will do things for us and to us. And as we think about how to do that in a secure fashion, we are introducing what I again call the continuous knowledge gap. New technology comes out, I need to figure out how to use it. Think of this like the developer learning to fly the plane as the plane is going down the runway. And the security person sitting in the back trying to figure out, well, what is this plane and what do I have to be afraid of here? So if you think about, for instance, S3 buckets, when those first were created and rolled out, by default, they were insecure, they were public. People made lots of mistakes configuring those because they just configured them and started using them. And, hey, isn't this great? Then as we learned through security incidents where we were accidentally leaking lots of our company data, it exposed that gap on how to secure that. Oh, geez, we should rethink this. So there was an approach on both the security side and the vendor side where Amazon now, by default, when you create an S3 bucket, it is private. So it is not open to the internet as it once was. So this is learning that happens along the way. So we have to be a continuous learning field. And this goes for development and this goes for security. And think about that lag. Developers are learning it, they're using it. We can't slow them down. They're moving these applications with this technology out to the world, and we have to come back and try to address those security concerns. So we have to be in the room with them, trying to understand what's going on. So the change in responsibilities is really a critical aspect here. If you look at the legacy software process, and this is, again, back when I started coding, I would write software, and that was the sum total of my job. When I was done, I threw it over the wall, and then someone in the quality department would run some tests against it and figure out whether it worked right, write up a bunch of bugs that we would then go and fix. After that was completed, we would send it over to security, and they would take a look at it and figure out what vulnerabilities were in there. Once we were complete with that and we had our release candidate, we'd have to go to a management meeting. Think of this, change board or cab, where we'd go and ask for permission to make a modification to production or to ship the software on CDs. So there was a process to do that. This is calendar process too. It's expensive. There's lots of important people there that make a lot of money, and it's expensive with regard to time. Meanwhile, we'd be prepping production. So systems engineers would order hardware from the vendors. They would show up on loading docks. They would bring it into the data center, rack and stack and cable it. Then your IT people would come in. They would configure and harden, install the operating system, etc. Once you had that release candidate approved, operations team would install it and monitor it. So this is your classic silo model. And this is the way companies were built back then. They had all of those silos. In the cloud native world, in the Amazon, you write it, you run it model, me, the developer, I build a feature, I have to write the tests for it. It is no longer an option. It's no longer, it is assumed now when you walk into a company as a software developer that the code you write has to work, and that you are responsible for testing it to making sure that it does. That same person has to validate the security of that feature, because we're in this flow model, single piece flow, where I pick up a piece of work and I need to get it done and I need to ship it. I have software now that approves the release. So I codify my policies. Instead of going to a management meeting and showing them evidence, this evidence is collected electronically and measured by tools. And we have a pipeline that knows when it's acceptable to move it along the pipeline. We now have software that can terraform that environment, build it up in a virtual world. And again, installing and configuring, or picking a container that it needs to go into, installing that software into that container and then moving it into production. And on the flip side, it's now the team that's responsible for monitoring and managing that application. So it's that same 6 to 12 people, that 2-pizza team has to do it all. So if you look at these side by side, on the left, their roles. Those were people that did those jobs. Now, those are functions or disciplines that developers need to have. And we need to understand how to do these things in order to get to that world of single piece flow. So this is where that cloud engineer concept comes from. The fact that you have to be multidisciplined, you have to look across that entire environment and know all of these roles as part of your job. And of course, the first one, and arguably the most important, is you have to be a great engineer. No two ways about that. And that is a hamster wheel in and of itself, with all of the things you need to learn around architecture, around languages, deployment models. How do you do this cloud native thing? And if you are going to do cloud native, are you going to be cloud specific? In other words, I'm going to target AWS, or I'm going to target Google or Azure, or am I going to be cloud agnostic and build some kind of layer in between that allows me to be multi-cloud? I also have to understand the open source ecosystem, the frameworks and libraries that I'm going to use to build the components of my application, understanding the licensing implications of those. I'm building API first. My leadership hopefully has codified some policies around technical debt such that I'm at least managing it. You're never eliminating it, but you need to manage it. And I'm trying to avoid rework. And again, when you're talking about DevOps and single piece flow, rework is the enemy. Quality is imperative. You can't release it if it doesn't work properly. And this falls on the developers in that DevSecOps model. This is where, TDD, or test-driven development, came from. It's the idea that we would write the tests ahead of time, and then when they all passed, we knew we were done. It's an incredibly hard skill to learn. We need to learn this over time and learn how to automate these things. And as we fix problems, we need to add to those tests, because it's obviously something that we missed in our initial implementation. So you got your regression testing, you got your unit testing, you have your functional testing. These are things that need to get written along the way, and it requires that discipline. That it is easy to think about, hey, I'm just going to get this done and I'll think about it later, but later never comes, and then you get bitten by it with an outage. Deployment models, understanding how to harden and configure the software that you're running. How do I pick the right container? Is it secure? Which ports are open? Is it too permissive? Do I have all this under version control? How do I think about, from an operational sense, what do I do with it when I have to change it? So this, being able to do this on demand and creating that kind of paved road that allows you to redeploy in bulk. Because in the cloud native world, I don't have one machine that runs my application. I probably have hundreds or thousands of instances of machines that run my microservice architecture. Of course, when we think about what goes on in a production environment, the fact that I don't want to log into a machine in production, and really I shouldn't, means that I have to have telemetry. I have to understand the health of my application. Again, this is something you learn over time on your specific applications, the things you should be afraid of, the things you should be measuring, the things you should look out for. How do I debug it and fix it? How do I get those alerts? We need to become resilient to failure, create anti-fragile code. And again, this is part of the learning process by living the pain of running your software and understanding that there's a memory leak there. So every 2 days, this thing is going to fall over under load. Those are things I need to go look at, because I don't want to get woken up to go fix those things. And I don't want to script, just knocking the infrastructure over as a typical operations person would, because they don't have access to the source code. They can't make those changes. These are things that I take pride in and I want to go and fix. And by living that pain, you become a better developer in the long run. Of course, one of the reasons we're here today is talking about security. We need to secure the applications that we build to the standards of our company. It needs to be part of the definition of done. So if you are not familiar with agile methodologies, when you pick up a piece of work, there should be documentation on what's called the definition of done. What are all the things that I need to know and do and test before I can declare this piece of work to be ready for production? Not kind of done or almost done, not done, but really it's thinking about, did I do everything? And that includes security. Oftentimes this is missing. It's an afterthought. We do it later when it's more painful. We have to think about how we fail fast, automate this testing. We want to, this concept of shift left is the same kind of thing we think about with QA. If we find it earlier, it's less expensive to fix. There are less decisions that now rely on your previously bad decision down the road. So if you find it earlier, there's less less rework to do. So if you think about knitting a sweater, if you drop a stitch in the first couple of rows and now you're 100 rows deep, really the only way to do that well and do it correctly is to unravel the whole thing back to that spot that you made the mistake, fix it, and then make sure that you're perfect the rest of the way. Incredibly hard to do, time consuming and aggravating. No one likes to do that. So this is why we need to integrate our testing early and look at it. The things that we do at the end, the tests that we run at the end, whether that be your quality tests or your security tests or performance tests or whatever, are really assurance. That means that we're making sure that people did the right things. Very often in my early days, you would skip your unit tests, you would check it in, it's a small change, what could it hurt? Then walk out the door, and of course the build was broken and everyone's aggravated about it. Having that discipline to do that, and this is one of the places where CI came from, hey, we're not going to allow that check-in to move forward unless it passes those tests. So thinking about your CI testing and your assurance testing at the end prior to that deployment in your CD pipelines. So you are a security professional. What do you do? What do we do about this problem? Because as we talked about, the developers are already in this knowledge gap situation, and we're one step behind them, at least. First and most important thing is to build relationships. There's this us versus them mentality. Those developers, those security people are slowing me down. Those developers don't listen. They don't do the right things. It can't be a function. It needs to be a name. Pete over in development, I was talking with him yesterday, and we were talking about these features and functions. It's harder to cast those kind of aspersions on a name instead of a function. It's very easy to do on the function. We all take pride in the work that we do. Developers are no exception. I am no exception. I took a great deal of pride when I was developing enterprise software in the work that I did. It is a craft. As security professionals, we need to respect that in the same way we want to be respected for our craft. And that means that we have to understand their challenges. In some ways, we're going to share their challenges. So we can't remain oblivious to how the sausage is made, because if we do, then we don't know that we provide help that helps. Sometimes we are slowing them down because of the way we do things, because we don't understand the implications of what we're asking for. So by having those conversations and by understanding how software is built, you gain a new appreciation for how you should aid the development team. And there are lots of books out there to go read. Top of it should be the Phoenix Project. That's a great read. It is a story, not a textbook, so very easy to digest. And it really gets you to helps you understand why DevOps works. Accountability. And what I mean by accountability is mutual accountability. The problem that we have today in our enterprises is that we're expected to have different outcomes and we're paid on those outcomes. So for instance, operations is paid to run with no outages. It's got to be glassy smooth, 5 nines, 10 nines, whatever you want to call it, where it has to be highly available and not disrupted. But developers are changing software constantly because that's what the enterprise is asking them for. We want you to change everything and we want you to change it fast. I dare you to walk to a lake, no matter how big that body of water is, drop a pebble and have it not create a ripple. It is impossible. Those two goals are opposite one another. So we are tugging on opposite sides of the rope. What we need to think about is how do we have this mutual accountability where it's not just software, it's secure software. And if we're measuring our developers on security as well as on speed, then they're going to start to think harder about security. If you don't pay them to write secure software, then they're not going to write secure software. There's no two ways about it. So you need that alignment in goals such that we can move forward in the same direction. We need tools. I love tools. These physical kind as well as the virtual ones. These tell you how you're doing, allow you to measure whether you're good enough. We have to have the development teams work with us to choose these tools. No one likes to be told what to do or how to do it. If we involve them in the process to make sure, again, going back to that relationship slide, that we're providing help that helps. We're finding tooling that integrates well into the ways that they work, because that's critical. Now, we do have to have our assurance tests, and maybe those can be different, but maybe they don't have to be. But we need them to be fast. We need them to be accurate. They need to be integrated and automated, because in the DevOps world, you have to automate all the things. When I graduated college, I did not have a degree in secure software development. I had a computer science degree, but in none of my classes did we discuss security. So our workforce is largely untrained, and it's our responsibility to help them. Now, I want you to be careful about this because we don't have a lot of time with them and we don't want to waste it. And people don't like to have their time wasted. So think about using the tooling that we're buying for them to measure where they struggle and then provide training that is tuned to those things. Use that telemetry or that feedback from your tools to inform your education program, and then use the output of your tools to measure the effectiveness of your education program. So there are multiple feedback loops in there. So developers code, they make mistakes, we find it with the tools, so we create education to help fix that. What we should see on the other side is now less mistakes that we should be able to measure with our tools. So that's a nice virtuous cycle to get better over time. So in conclusion, I want you to understand that a lot has happened in the last 5 or 6 years, and it will continue to happen. The pace of development and change is accelerating. We're not going to get bigger teams. We will not go back to a world where we can have specialists any longer. So on our DevOps teams, they need to be generalists. No company is going to say, hey, that's fast enough, you're good now. They are going to always ask for more, and they're going to ask for it faster. I'll stress again, mutual accountability. If you get to mutual accountability, if we're all being measured for the same things, it opens up those conversations where development can come and say, hey, this security thing that I'm going to get graded on and paid for in my yearly bonus, can you help me here? Because I kind of like my bonus and I'd like to get it. So again, you pay them for what's important, measure them on those things, and reward them. We need to build these cross-disciplined, multidisciplined individuals in our enterprises. Help them be good at all of the things, or good enough at all of the things to be able to do this better. So again, providing that tooling, providing that training. They need to train each other. If someone has a strength in one area and not another, so talking to my development leaders here, we need to cross-train them on these things. There's always a place for expertise in a company, but that's the small. The large is the general, and being able to give that uplift from those experts. We have to know what they struggle with. We need good tooling to be able to measure that, and to measure the impact of that training that we're going to give them and the onboarding that we give them. Think about changing your hiring profiles. Look for people that are lifelong learners, people that like to dig into that world and like to learn all this new stuff, because it's going to keep going. So I thank you for your time. I'm going to go back on camera now and turn off our screen share. Go back on camera and see what we've got for questions.
All right, that was a very excellent presentation, Peter. We do have a few questions that already have come in. One of them is, how do I create application security policies that work?
Well, all right, so that's a great question. And really, when you think about policy, what we want to get to, and we're going to cross back into some of those streams that we talked about in the slides, is that mutual accountability. I was talking to a CISO years ago, and he said, I'm going to enforce my security policies on developers. Now, I don't know how that comes across to you, Dave, but that's a little aggro for me, and it doesn't make me feel good. Right. No one likes to be told what to do or how to do it. I stopped him. I said, geez, I understand what you're trying to do and why you're doing that, but wouldn't it be better if they embraced it? So this is, it's critical to explain the why behind. Why do we have this policy? What is it meant to do? It's not just, I come down the mountain with the stone tablets and my 10 commandments and say, here, you got to do this. It is in bringing them into the discussion, figuring out how high the waterline can be based on the maturity that we have today, painting a picture of where we want to go, such that we could say, hey, the mountain's out there and we need to climb it, and here's how we're going to get our tooling up to get there, and doing it together. So when you have that mutual accountability and you have those relationships, it opens up those conversations and allows you to create a policy that's going to work for your company.
Mm-hmm. Interesting. One of the things that I've always found in having a lot of discussions with people when they're asked to adopt some sort of a new thing that they hadn't done before, like Agile or DevOps or a lot of these things, it's non-prescriptive. So the answer is always like, well, it depends on your organization, and it depends on your culture, and it depends on these things. And I think that might be part of the initial stumbling block that people have, in that I think they want to go out and just buy the thing that's going to get them to where they want to go, or they want to be
Right.
told, okay, if you're doing Agile, you must do X, Y, and Z. It's not X, and if you want Y, fine, and if you want Z, well, maybe. What are your thoughts on that?
Yeah. So we're making software, not foie gras. So, but what I mean by that is we don't want to force it down someone's throat. And when we think about that prescriptive, yeah, there are guidelines. There are some good practices. If you look at books like Accelerate by Dr. Nicole Forsgren, it talks about the indicators. If you do this, you see this result. Now, you may not do this in the same way in your company, but understanding the fact that when you lean into these methods and these practices, that you see these results. Work is hard. I mean, we get paid to do hard work. This is a knowledge-based economy, and the kind of money that we pay to our development and security professionals is large. So I get the fact that people are busy. We need to prioritize the right things and then lean into those with hard work. And those are the things that I really enjoy. So yes, you want it to be prescriptive, but it can't be. You want to have a best practice that you can just blindly follow, but that it doesn't exist. None of these things work the same way at every company. Culture is different, whether that be the culture of the company or the culture of the company. The country that you live in. There's so many variables there that you have to find something that will work for you, that gets you in the right direction. And again, you have that maturity model where you're just starting out and just learning how to do these things, and it takes time. It takes repeats. It means you have to be open to failure and say, well, that sucked. Let's suck less tomorrow. That's been my mantra for years, is like, look, I know I'm going to make mistakes, and if I'm afraid to, then I won't change.
Right. Excellent. So we have a couple of more questions that have come in from our attendees. One of them asks, and this is a good question, which is a better approach to shift left security? Making security experts part of a development team, or getting developers trained on security aspects and tools?
Great, that's a great question. So I think those are the same thing, though, right? So having security experts on my team, I would do that by training security into my development teams. Now, you can't start there. And the question is, how many people do you have? I mean, geez, it would be great if I could put a security professional on every single team. The way I used to do this in earlier days when I was a development leader and a scrum master is that what we would do is we would take a look at every story we were going to take into a sprint. I would sit down with a security professional on our team. Outside of our team, we would have a regular cadence where we would go through and look at these. And we would look at, all right, what are we afraid of? What security controls do we need to have here? What do we need to think about from a security testing point of view, from an implementation point of view? So you can start there. You can also look at, creating a security champions program where you are up training individuals on those teams to become your eyes, ears, and mouth in those development discussions, because developers talk about software all day, every day, and your security professionals don't have that kind of time to be sitting around to be there on the fly as a fly on the wall for every one of those discussions. So think about how do you get them to understand the things that they should hear that should trigger a security response. Oh, that sounds interesting. Either I know the answer, or I'm going to go ask and get trained on that answer.
That's great. Another really excellent question from one of our attendees. He writes, I'm a little old school. Any suggestions on how to become a good, quote, cloud engineer?
The only way to get good at something is to do it. So there are lots of free ways to do that. Writing the software, writing that terraforming, creating your own components, creating your own software. If you want to do it, if you want to be good at it, then you need to do it. So you need to find a place, a sandbox that you can play in to get better at that craft. There's certainly lots of reading to do, but I find that until my hands hit the keyboard, I really don't know whether I understand it.
Good
And
point.
sometimes it's about teaching. So I did after I started doing web development, I started to train people that were changing careers. Back in the late 90s, early 2000s, there were lots of people, I mean, hairdressers and cab drivers that all wanted to get into web development. So as I started to teach it, holy mackerel, did I learn how much I didn't know, right? So
Right.
for me, it's about I needed to be an expert to be standing in front of that class. So I went out and I learned all the specs. I went to W3C and I downloaded it and I studied it and I knew it backwards and forwards. So you could take either of those models, training or doing. I would suggest a combination of the two.
Hmm. Excellent. Okay, another question that we have. There are many choices for security tooling. You have SAST, DAST, SCA, and things. Where do people start when they're looking to bring security tooling into their organization?
Right. So if you're just starting on that journey, if you look at Gartner, they term SAST and DAST as foundational. They have been around the longest. They are the most mature, the most accurate. Those are the technologies that I would start with. And they also happen to be some of the least cost. So some of the newer technologies like SCA or software composition analysis is incredibly important. And I wouldn't want to not have it in my program. But as you think about rolling out a security program, I would stack rank applications. Which ones are the most important? Which ones are the least important? And there's lots of ways to bucket those: internet facing, not internet facing, financial transactions or not, regulatory impact or not, the kind of risk profile that you might have on those, the kind of answers of like, what am I afraid of here? Where I would want to have for my most important applications, all of them. I would want to have SAST, DAST. I would want to have SCA. I would want to have IAST against those applications, but normally you can't afford it and you can't roll it out all at the same time anyways. So think about what you can cover for the least amount of money. SAST will shake out a lot of the really easy stuff to find. That doesn't mean it's necessarily easy to fix, and it's not because individual vulns are not easy to fix, but because when you look at applications that have been around for a very long time, you're going to find lots of stuff you wish you never knew about. There'll be hundreds or thousands or tens of thousands of vulnerabilities in that software, depending on its age, that you're going to have to go and think about, well, what are my priorities here? So it's a great way to start to understand where you are from a security aspect.
Hmm. Well, I see we're getting close to the end of the hour. We do have time for one more question. And this kind of feeds off of the prior question. So this person wants to know, how do I fit my tooling into my development methodology?
Right. So if we go back to the slides and the learning the methodologies, so it really means sitting down with those professionals. And there are still some applications, lots of them, probably more than should be, that are still using waterfall. Lots of people have adopted Agile or Agile Fall or some Frankenstein version of Agile. Not many are doing DevOps in a way that I think is productive, but I'll leave that argument for another day. You have to go in and talk to them. You have to understand what their requirements are, what tooling that they use, how your tooling can fit into theirs in the way that they do business. Because if you're seen to slow them down, then you are going to get pushed aside. They will walk past you, they will run past you, they will sneak past you. So by including them in those conversations to understand what's the right thing to do and how do we get after it and how do we build a program, up our maturity game. If you think about playing a sport, so I coached soccer, and actually I'm coaching again now, so I've been coaching for about 20 years now. When you first start playing a sport, the sport is so much faster than you are. You are reacting to things after they happen. As you practice and learn more, you start to think faster than the game. And when you can slow things down to that level, you look like a rock star because you knew something was going to happen and you were able to take advantage of it before anyone else was. And it's really about that level of maturity in your organization, in your development and your security organization, to think faster than development. to think faster than you're building the software, such that you see these things coming, you have this continual improvement process, and you continue to take that feedback of, well, that didn't work so well, how are we going to adjust for it, and turn that into real work that gets you better.
Excellent. Peter Chestnut, CISO of North America for Checkmarx. Thanks so much for being with us today. Appreciate the presentation.
Thanks for having me. Appreciate it.
Also would like to thank Checkmarx itself for sponsoring today's session. And of course, thanks to all the attendees who hung in with us this afternoon. Thanks for your time as always. And until next time, I'm Dave Rubenstein, Editor-in-Chief of SD Times. So long for now.